Welcome back, Physical Science 20. This is section FC3.4, calculations involving limiting reagents. So we'll look at determining what the limiting and excess reagents in a variety of chemical reactions through stoichiometric calculations are. So kind of part one, we'll be looking at given moles of each reactant and figure out which one is limiting. And then the second part will be starting off with grams of each reactant and then figuring out the limiting reagents. So if we look at this involving mole amounts, which will be this first part, if you're given the quantities of two different reactants, you first have to figure out which one is the limiting reagent. And of course, that's the one that's going to be used up completely. Then you can use that amount to figure out how much product will be produced. So if we look at this first example on your sheet, the following reaction occurs when 2.8 moles of titanium 4 chloride reacts with 5.4 moles of magnesium. So what I like to do is, if you're given mole amounts, simply write those above each of the species in the equation. So titanium 4 chloride, so we have 2.8 moles of that, and 5.4 moles of magnesium. And of course here we have a 1:2 ratio. Okay, we can almost figure out this one without going through the steps, but we'll go through the steps just to see how this comes together. So we have to figure out what the limiting reagent is first. Then once we know the limiting reagent, we'll be able to figure out how many moles of titanium metal are produced. So whichever one of these is used up, we'll be able to figure that out. And then to figure out how many excess there is, how much of the excess reagent remains after. So we'll look at this two different ways. We'll try to use up all the 2.8, see if we can do it, see if we can use up all the 5.4, and then we'll get an indication in terms of which one will be limiting and which one will be excess. So over here, part A, we're going to do that first. So let's figure out if this 2.8 gets entirely used up. So given 2.8 moles of titanium tetrachloride, okay, and if we look at how that all comes together here, for every 1 mole of titanium tetrachloride used, we need 2 moles of magnesium. So again, we're going from here to here, before, after, 1 to 2. So for every 1 mole of titanium tetrachloride used, we need 2 moles of magnesium. And of course, you know if you're doing this right, if you are able to cancel these units. Moles of titanium tetrachloride on top, cancels with moles of titanium tetrachloride on the bottom. So 2.8 times 2, that's going to give us 5.6 moles of magnesium. Okay? Before we worry about analyzing that, let's do the reverse. Let's see, okay, what if I had tried to use up the 5 moles of magnesium? Okay, according to that, 2 moles requires 1 mole. 2 moles of magnesium requires 1 mole of titanium tetrachloride. So again, yes, units on top cancel with units on the bottom. 5.4 times 1 divided by 2, that's going to give me 2.7 moles of titanium tetrachloride required. And up here, required. So let's take a look. Back in this first step, if I try to use up all this 2.8 moles of titanium tetrachloride, I need 5.6 moles of magnesium. Do I have it? No, I don't. I have 5.4 moles. So we can say here only 5.4 moles available, though, or don't. We don't have enough. So this step simply cannot work. So that means logically that the reverse step must work. If I try to use up all the 5.4 moles of magnesium, I need 2.7 moles of titanium tetrachloride. I got 2.8. So that one does work. That's the method I'm going to use for that. And if we jump, we could actually do part C right now. We know how much extra we're going to have. 5.4 requires 2.7, but we have 2.8. Hey, so we can figure out part C right now. I'm just going to scooch down to the bottom of the paper here. Part C, to figure out the excess, I could say I have 2.8 moles of titanium tetrachloride available, because that's what I have here. I have that much available, but I only require 2.7. So subtract 2.7 moles titanium tetrachloride required, I guess we could say. And that's going to give us 0.1 moles titanium tetrachloride excess. So, and you could have saved that for later, but I just chose to do it now because, hey, we could. Okay, so now that I know, so what that tells us, if I try to use up all the 5.4, it does work. So therefore I can make a little statement. Therefore, magnesium is the limiting reagent, since all of the 5.4 moles are used up. And titanium tetrachloride, we say, will be the excess reagent, since 2.7 moles is used up. All right. Hey, so now that I know that 5.4, this is the limiting, this is excess, and it's the limiting that I'm going to use to figure out how many moles of product I'm going to be making, in this case titanium. So I use that when figuring out part B, determine how much product is produced. Let's look it up here. Part B. So 5.5 moles of magnesium, that's my limiting reagent, right? And according to this, 2 makes 1. 2 moles of magnesium makes 1 mole of titanium. And again, you know if you're doing it right on the wrong side of town, if you can do that. So 5.4 times 1 divided by 2, 2.7 moles titanium produced. So there we go. There's the answer to B. So we've looked at that. So the key thing here is figuring out what the limiting reagent is first. And once we know that, we can figure out how much product is produced because we use that limiting reagent to figure out the product. And then, of course, you may be asked, well, how much excess is left over? So we only require 2.7, but hey, we have 2.8. So, of course, we figure out how much extra there is that we have left over. Okay, on the flip side of that piece of paper, there's another question here, very similar. A nitric acid spill is neutralized by adding sodium hydrogen carbonate. A reaction occurs when 2.3 moles of nitric acid is combined with 2.0 moles of sodium hydrogen carbonate. Now this one's a little bit easier because it's a 1-to-1 ratio. But still, take a few minutes now. Just stop the video. Part 2 we'll look at going through this one. But see if you can do it first, and then I'll see you in a bit. Okay, see you in a bit, Physical Science 20.